Video number 200, graphing a piecewise function. Here's the website for the YouTube people. Come on over and check it out. Let's take a look at video number 200, graphing a piecewise function. Actually, we got 4 different piecewise functions for you here. And the first one is f of x equals 5. Then this is read. F of x equals 5 whenever x is less than 3. And x whenever x is greater than or equal to 3. Now it looks like a bunch of numbers and letters, but let's break it down. The y values will be 5 when the east-west values are 3 or less, right? The height, the y values, the height will be the same thing as x when we are looking at being to the right of 3 or at 3 with the equal sign. So here's how this is going to work. If we were asked to just simply graph the function f of x equals 5, I think we would all agree, right, that we're looking at a height of 5. So it's a pretty boring line. It's just 1, 2, 3, 4, then 5. And we have a horizontal line going through there. However, this is telling us here that we're only allowed to do this for when x is less than 3. So we're going to go over to 3. 1, 2, 3. And we're going to stop there at 3. And we're going to go ahead and only graph this in this direction. Okay, now, so in other words, the height is 5 when x is less than 3. So here's x right here. There's 3. And then less than 3, we have a height of 5. There you go. Now, we're going to get into open circle and closed circle here. We're going to put an open circle here at this position, and we'll explain a little bit more of that later, but basically the premise of it is this, is that when x is less than 3, we have a height of 5. So that's why we put an open circle at 3, because at 3, everything changes. When we actually compute, here's one of the things you're going to want to do for all your piecewise functions. Always calculate the value that's being used for equals for the inequality. All right, so what is the function f at 3? So what's happening to f of 3? You're going to get a total of height of 3. So you're going to go to the right 3 and then put a 3 here. All right, then greater than 3, we're going to do the line f of x equals x, y equals x. Okay, well, that means f of 4 is 4. Right? F of 5 is 5. So you're going to end up with this line in this direction. Okay? So this is what's happening. A height of 5 when we are less than 3, to the left of 3, we have a height of 5. And then 3 and greater, we have this line y equals x. Okay? That's all it is. That's why they call it a piecewise function, because it's just broken up into 2 different pieces. 5 is the height when x is 3 or less. X is the height when x is 3 or more. All right, here's the next one. G of x. G of x equals negative 3x plus 6 when x is less than 0, and x plus 2 when x is greater than or equal to 0. Okay, so one of the things we're going to want to do here is, again, let's pretend as if the function said y equals negative 3x plus 6. Let's graph that momentarily in our head at least. Well, the shortcut would be to use the slope intercepts. We're going to go up 6, 4, 5, and 6. We have a slope of negative 3. So we would go down 3, 1, 2, 3, and to the right one, we'd put a point here. Or we would go up 3, 1, 2, 3, and to the left one, we'd put a point there, and we would have this line. So this is the line y equals negative 3x plus 6. Now we know that, so let's build off what we know. Then x has to be less than 0 for this graph. So x is less than 0. Well, where is x equals 0? Here's x equals 0. Here's x is less than 0, right? X is 0, x is less than 0. So therefore, we're only going to graph in this direction. Okay? For that line. Okay? Then, so in other words, to the left of 0, you're going to do this, But to the right of 0, you're going to do that. Now, by the way, this should be definitely what? An open circle for some of the people that are, you know, are catching on to the pattern. Whenever the one says just strictly less than or just strictly greater than, we're going to put an open circle. All right? And the reason is because what is g of 0? G of 0 is what? Well, this is when x is greater than or equal to 0. So g of 0 is definitely 0 plus 2, which is 2. G of 0 is not 6. G of 0 is definitely not 6. It's definitely 2. However, g of like negative 0.0001 is definitely real close to 6. Okay, just to point that out to everybody. So you're talking about just to the left of 0 is definitely closer to 6. But right at 0, we're going to use 2. So that's important for us to put that down. Now, actually, we're going to erase this. To that point, it's not on the graph. That was just how we were looking at the original line from the first part. Okay, so now we're going to graph y equals x plus 2. All right. We're going to graph y equals x plus 2. And we're going to do that for whenever x is what? Greater than or equal to 0. Okay? So then we have a slope of 1, and again, we're just going to get the other values. There's a 1 here, there's a 1 there, and we're in good shape. So then this is the one that has the closed circle. So that's your closed circle, that's the open circle, and we should be in good shape. Okay? All right, next one, h of x. This is 3 parts. Okay, now whenever you have these 3 parts, I suggest you divide the graph up into a couple pieces, or we actually could have done that, especially in this first one. The first thing we could have done was located x is 3 and drew a dotted line down the line x equals 3, and then said what happens over here, what happens over there are 2 different things. So let's do that here. Let's draw a line x is less than or equal to 0, so that's definitely the y-axis. Okay, then you have x is less than 3, so 1, 2, 3. So we're going to draw a line through there. So what's going to happen is we're going to have 3 parts. We're going to have stuff that's going on over here, here, and there. There's your 3 different places. Well, negative 2, that's just a height. That's just a height of negative 2 whenever we're less than or equal to 0. So we're going to have this boring horizontal 0 slope line going this way. And this was actually going to be a closed circle at that position, because h of 0 is definitely negative 2, because whenever, you know, we have the equal sign with the 0, so therefore negative 2. All right. Then we would have what's happening between 0 and 3. So what's happening between 0 and 3? X is 0 and x is 3. That's what's happening between here. So then we would say, all right, well, 1, what's h of 1? Well, h of 1 is definitely 1. What's h of 2? That's definitely 2. H of 3, that's definitely 3. So then we would go through here and we'd graph this. So h1, 1 is 1, 2 is 2, and x is 3, you get a height of 3. So what we would have here is a line like this, and actually, we should probably graph it a little bit better, because actually, as it turns out, we're going to have an open circle where? We're going to have an open circle at 0, 0. Okay, and the reason is because if you took a look at like h of 0.001, that would definitely be 0.001. I'm sorry, I put 3 zeros. Okay, yeah. So anyway, real small values, real small positive values would exist right in between here. So that's why we would then put an open circle here, because h of 0 is almost 0. This is almost true. This is definitely false, but it's almost true. See, because h of 0 is definitely negative 2. It's down here. But it's almost true that you could almost get away with that. That's why we put an open circle, because of this small value here. All right. Then we do the third part, 3x plus 1, for when x is greater than 3. We would graph the line, y equals 3x plus 1. Now, what we could do is this. You could go back to your the way we would have graphed it if we were over here, and then do your up 3 over 1, up 3 over 1, up 3 over 1, and do all that. However, it may be easier just to simply plug in h of 4. H of 4 would be what? 12 plus 1, which is 13. So we go up to a 13 here, and at 4 we'd have a 13. Okay. At 5, what would you have? A 16. Okay. And it might just be easier to do it this way. And then, of course, if we were looking at, this is 13, if we were looking at h of 3, let's just say you wanted to plug a 3 in here, which you wouldn't. 3 definitely goes in here, but if you plug a 3 in here, you'd get what? 9 plus 1, you'd get a height of 10. So that would be where our open circle is, because we would consider plugging in a 3 into the third part of this piecewise function. So then we would graph. There's our line right there. So basically you have 3 pieces for this one, and we're in good shape. All right, next one. And I meant to just have 2 parts here, and we're gonna just cross that out. All right, k of x. So k of x equal 4x minus 5 whenever x is less than 3, and x squared minus 10 whenever x is greater than or equal to 3. So what you'd have here again is two parts, and so don't get scared here. This is just a quadratic. It's no big deal. Let's go ahead and do this. So you got y equals. Well, I'd call it y, but yeah, k of x. So y equals 4x minus 5 whenever x is less than 3. So what we would do is go ahead and pretend as if it was just dealing with a 0. We would go down 5, 1, 2, 3, 4, 5. There you go. Slope is 4, so we're going to go up 4 and over 1, right? Up 4 more, so 1, 2, 3, 4 over 1 more. There it is. Now, we would then do this for when x is less than 3. So we would definitely do this until we get to here. So actually, this value here would be an open circle, wouldn't it? Right? So then we would have a line like this. Okay, well, I'll just make that bigger, and there you go. No big deal. All right, then x squared minus 10 whenever x is greater than or equal to 3. So what can we say here? Well, what is k of 3? K of 3, is it 12 minus 5, 7? Or is it 9 minus 10, which is negative 1? It's definitely 9 minus 1, which is 9 minus 10, which is negative 1, because we're looking at x is greater than or equal to 3. So we would then graph a negative 1 here and put a closed circle at that spot. Then we would consider k4, which would definitely be what? 16 minus 10, which is 6. So then we would go, okay, 1, 2, 3, 4, 5, 6, and that would be at 4. 1, 2, 3, 4, 5, 6. Okay, here we go. All right. Now, is this a line? No. You got to understand quadratics. We're dealing with a quadratic shape, so we're going to be dealing with this right here. So it's going to have a curve to it, right? So if you remember quadratics, and of course, if you plugged in 5, you would see it's 25 minus 10, which is 15, so you'd be way up here. So you would definitely have a quadratic shape going on here. All right, so you could see how you could break these up into multiple pieces, and hopefully this gives you a little bit of an idea. Now, one of the things we could have done again at the 3, and it looks like I only used 0s and 3s in this video, but you could have drawn a dotted line right down the middle, right in the beginning of each one of these to start off. You know, you could have said, okay, at 0, we're going to do something on the left of 0, something to the right of 0. Here, you're going to do something to the left of 3, right, the vertical line, and something to the right of the vertical line, 3. And of course, we have our 3-pieced piecewise function. You're going to have something to the left of 0, something between 0 and 3, and then something different greater than 3. So this is just telling, it's like a time, this is the timeline, all right? And this is just the various heights within those timelines. Okay, so good luck to you, and we'll talk to you later. Yeah.